Hello everyone, Namaskar. In our previous video, we had discussed about the differential calculus. The whole sum quantity was given and we had divided it into some parts. The reverse process of differentiation, the inverse process of differentiation can be called as integration. We had been provided with the slices. We had been provided with the parts, and once they are joined together, we get another quantity, another function. This process is called as the process of integration or integral calculus. There are several formulae of integration, but we will focus on those formulae which are frequently used in the field of physics, in our course, in our syllabus. I'll give you an example. Consider a tap is running in a tank, water is coming in the tank, and the rate of flow of water coming out of the tap is increasing with time. If the rate of flow of water is increasing with time, definitely the amount of water collected in the tank will also go on increasing. And if we want to calculate the total amount of water present in the tank at a given instant, say, or when it got fully filled up, then the process of summation, the amount of water collected in individual intervals, and then they are added up. This process of summation is a longer process. It is a tiresome process, slightly complicated, and that is why the help of integral calculus with the formula of integration, this problem can be overcome. So today we are going to discuss about the integral calculus or integration. For that, we will express it mathematically. As you can see, if differentiation is done, if the differentiation of this x raised to n is done, we get n times x to the power n minus 1 say. This is the formula that we had used earlier. In that case, the integration of this part must give us the original quantity, original function. So, if we are having the derivative of y with respect to x, dy by dx is equal to f of x. Dy by dx is equal to f of x. Then we can write the opposite process, reverse process of this integration of this f of x with respect to dx must be equal to y. Clearly, this f of x is called as the integration of y. This function f of x was the derivative of y, and if we are gathering all these f of x, the small slices, when we are gathering one after the other, we are going to get the whole sum quantity. If this y is another function which is dependent on x, value of x, then we can write integration of f of x dx is equal to another function f of x plus c. This c is called as the constant of integration. This c is called as constant of integration, and where we are getting the original function. That means originally this function was differentiated, we got this, and when we have integrated this one, we must get the original function. I'll give you some examples based on the same. Before that, understand what is exactly the integration. Also, this symbol, an elongated S this symbol is a symbol of integration. When nothing is given here or here, then this is called as indefinite integral. And if something is given as the lower limit, as the upper limit, then this is called as finite integral. That means we have been provided n number of slices of cucumber shape. So the length that we are going to get of the cucumber will be bit wider and it will be up to infinity. But if the number of slices of cucumber is given say only 10, then definitely we will get the value, the length of the cucumber will be finite, and this is called as finite integral. When no limits are given to the integration symbol, it is called as indefinite integral. So let me read the formulae, some basic formulae of integration which are frequently used in physics. See, we have used the first one, d by dx of x is equals to 1. You take this dx in multiplication, so 1 into dx you will get dx. So integration of dx must be equal to x. Integration of dx is equals to x plus c. This C has its own importance when we are dealing with the uh, indefinite or infinite type of integral. Then the value of C can be anything. I'll give you an example afterwards. First of all, just understand dy dx of x to the power n, differentiation of x to the power n, we got n times x to the power n plus 1, n minus 1. Opposite to this, integration of x to the power n into dx must be equal to x to the power n plus 1 upon n plus 1 plus c, constant of integration. We have differentiated the given polynomials in the three functions u, v and w which were dependent on x. dy dx of u plus or minus v plus or minus w is equal to du by dx plus or minus dv by dx plus or minus dw by dx. Opposite to this, integration of a function u plus or minus v plus or minus w into dx is simply integration of u dx plus or minus integration of v dx plus or minus integration of w dx. These are the formulae that are there. Also, integration of 1 by x into dx gives us log base e x plus c, constant of integration. dy dx of sin x is equal to cos of x is there in differentiation. If I will integrate this part, integration of cos of x dx must give this sin x, and you can see here integration of cos of x dx is equal to sin x plus c. Similarly, differentiation of cos of x gives us minus sin x, and thus integration of sin x dx we get minus cos of x plus c. One more formula we can take here, like integration of a constant c into dx. In this case, c will come outside and we will get integration of c into dx. This is cx. The constant c is the coefficient of x, and that we will take in the numerical. I hope you have understood the formulae. There are bit more formulae, few formulae which you are going to derived in higher classes in class 12th, that too in mathematics. And thus, these are the formulae that we will need for the work in physics. Let me show you the actual use of the same. Let us talk about the integration constant. Suppose x square plus 5 and x square minus 2 are the two functions. If differentiated, we will get this as 2x plus 0 or equal to 2x after differentiation. And after differentiation of this, we will get 2x minus 0 say, or that is 2x. Both the functions, this x square plus 5 is differentiated and x square minus 2 is differentiated, we are getting 2x here. And thus, if opposite is done, integration of 2x dx, we must get as x square plus a constant c here, and in this also integration of 2x dx, we must get as x square plus a constant c. Now this constant c is unknown to us if we are starting from this portion. And clearly these two functions x square plus 5, x square minus 2, they are differing, they are having a difference of a small portion, and this is the role of constant of integration. These functions, they are varying with a common difference, and that common difference can be called as the constant of integration. This constant of integration comes only in the infinite type of integral calculus. When we are having finite type of integration, then the constant of integration is not important there, it becomes 0 say. So clearly this is the role of the differentiation, this integration, constant of integration c. Let me give you some examples based on the formula that we had obtained. First of all, let us differentiate one quantity, one function. Suppose we want to differentiate 3x square plus 2x minus 5. This is the differentiation. This is the value that is given to us. Y. Let y is equals to, y is the function of x, y is equals to 3x square plus 2x minus 5. If I will differentiate it, I am going to get dy by dx is equals to, directly I am doing it, 2 into 3, 6x plus the power of x is 1 here, 1 into 2, 2 x to the power 0, and this is going to come as minus 0, say we will get 6x plus 2. This is our dy by dx. The small portion obtained from a wholesome quantity. Now let us integrate it, the reverse process. If the question given like integrate 6x plus 2, one must remember that this quantity given us to integrate is in the form of dy, small slice. So let dy is equals to 6x plus 2. Hence integration of this dy into dx will give us integration of 6x plus 2 dx. Clearly this is going to come as 6x, integration of 6x, I am using the formula of u plus or minus v plus or minus w, integration of 6x dx plus integration of 2 into dx. This 6 is constant, take out of the integration as we have done in this case. We are going to get x into dx plus 2 outside the integration symbol, 2 into dx. This will give us 6 into x square by 2. How have I done is, see, x is having power 1. So using the formula x to the power 1 into dx, we get x to the power 1 plus 1 divided by 1 plus 1. That means x square by 2. So I have written it here, x square by 2 plus 2 into dx. This will come as integration of dx is always equals to x plus constant c. I will take it here. 2 into 2, 6 divided by 2, we will get 3x square plus 2x plus c. This was the quantity that we had initially. This is our y. Integration of dy will give us y. So clearly our final answer is 3x square plus 2x plus c. This c we don't know. It was here in the earlier case, it was minus 5. So you can write it minus 5 or else keep it as it is. Clearly, when we had integrated this dy with dx, we are getting the total quantity, wholesome quantity equals to y. I hope you have understood the concept. We will take some more numericals, more questions based on the same. Initially, we had started from the differentiation and then we had integrated. Now we will directly integrate the terms. We will go step by step. Integrate the following. First is there, say x square. So here we have been given dy is equals to x square. So integrating dy must give us the quantity y. So I will take it y is equals to integration of dy, that is integration of x square into dx. This will give us x square. We will use the formula x to the power n. So n is 2 here. I get x to the power 2 plus 1 divided by 2 plus 1 plus the constant of integration c. This will come as x to the power 3 divided by 3 plus c. This is the y, the wholesome quantity. Also, second part we can take, integrate 4x raised to 4. So how will we get it? 4x to the power 4. Let us keep it x to the power 3 say. So here let dy is equals to 4x cube. Integration of dy is equals to y. So I will take it y is equals to integration of dy, that is integration of 4x cube into dx. This 4 is constant. Coming from this, we will take it outside the symbol of integration, 4 into integration of x to the power 3 dx. Using this formula, remember this formula is very important in physics. It will be frequently used. Integration of x to the power n into dx gives us x to the power n plus 1 divided by n plus 1. So 4 into x to the power 3 plus 1 divided by 3 plus 1. This will give us 4 into x to the power 4 divided by 4 plus constant of integration c. Since we are doing infinite integration, clearly this 4 and 4 will get cancelled out. We will get x to the power 4 plus c. This is our y. Now you will say, all these things are okay, but where exactly do we need this? So for that, let us discuss about the finite integral. You can take any function, any numerical, and you can integrate it, or else start from differentiation and then obtain the integration. We will obtain dy by dx first, and once again when it is integrated, we should get the same function. Now let me give you an idea about the finite integral. In finite integration or definite integration, we had been provided with the two limits. Basically, suppose we are having a function, say f of x dx. F of x dx is giving us another function f of x. In this case, if the limits are applied from a to b, this a is called lower limit and this b is called upper limit, then we can get the final answer as the function at b. I'll write it as b minus f of a, f of b, x minus f of a, x. A new function which is dependent on x, and we will need to subtract the values of these two at different points. Let me give you an example, a very simple example. Find integration from 1 to 4 of x square dx. Here we had already here, we will try to obtain the integration of 1 to 4. X to the power dx gives us, first of all, find out the value of x to the power 2 dx. What is the formula? X to the power 2 dx. This will come as x to the power 2 plus 1 divided by 2 plus 1. In finite integration, there is no rule of that constant c. So we will take it as it is. 2 plus 1, lower value 1, upper value 4. Clearly, this will give us 3. X to the power 3 divided by 3. Add the two values 1 and 4. So put this value 4 here. 4 to the power 3 divided by 3 minus 1 to the power 3 divided by 3. This will come as 64 by 3 minus 1 by 3. The answer that we are going to get, 64 minus 1, this is 63 by 3. Or else divide it, we will get 3 to the 3, 2 and 1. 21 is the answer of this finite integration. Now, where exactly do we need it? Suppose the force exerted on an object is changing with time. If the force and displacement graph is drawn, so the force is increasing and the displacement produced by it different. So we will try to find out the work done in this small portion. This will be called as dw is equals to f into dx. In this portion, the force can be considered as the constant for a very small time interval. So we will obtain this dw first, and then the total work done w can be written as integration of small dw. Here we will need it. Also, One formula we can obtain for the velocity time relation that we had studied in class 9. See, obtain velocity time relation, obtain velocity time relation using integral calculus. First of all, what is the velocity time relation? It is the equation for constant acceleration v equals to u plus a into t. Now, how to obtain this relation using integral calculus? It is simple. By definition, acceleration a is equals to dv by dt. Change in velocity upon time. I take this velocity v. Change in velocity upon time, a is equals to dv by dt. So clearly, dv is equals to a into dt. Now when time t is equals to 0, we have velocity is equal to initial velocity u, and when time t is equals to t, we have velocity as the final velocity v. Thus, we will integrate this in the given limit. So, first of all, we can take integration of dv from where to where? From u to v is equal to a is constant. I am taking it outside the symbol of integration. A 0 to t dt. Now this is the finite integral that we are having, and we can obtain it. This is going to give us velocity. Integration of dv is equals to v. Lower and upper limit we can take it here as uv. Remember, this is variable and these are the values. So v, this final velocity, initial velocity is equal to a will come here. Again, integration of dt will be t. Lower limit 0, upper limit t. Hence, the formula that we are going to get is equals to this upper limit v minus u is equals to a t minus 0. And this is your final equation. V is equals to u plus a into t. Which we had obtained using the integral calculus. Remember, I have taken those formulae which are a bit more important, frequently used in the field of physics, in kinematics, in work energy theorem, then in gravitation and all. So, you can just pick up a book, use the textbooks, use the reference books, and try to solve the different questions based on the same. This differential calculus and integral calculus are bit important for the study of physics.